This is a lesson for Chapter 7, Section 2, Multiplying Powers with the Same Base, day number 2. So first one, we're going to simplify expressions with rational exponents. And so let's take a look at what those represent. Well, first of all, rational exponent means just typically we have a fraction as an exponent, and what we have is the numerator represents the power that we're going to raise it to. The denominator of that fractional exponent is the root. And so what we're looking for here are 4 roots of 16, and then we're going to raise this to the first power. And so when I do that, I'm looking for 4 numbers that multiply to make 16. Well, the 4 numbers are 2's. 4 2's multiply to make 16. So that's what that is, 2, and then to the first power, which is just going to end up being 2. Well, over here we have 3 numbers that multiply to make 27. Then we raise that to the first power. Well, the 3 numbers that multiply to make 27 are 3's. And so 3 times 3 times 3 makes 27. So that tells me that the cubic root of 3 is, or 27 is 3. We raise that to the first power, and that just stays 3. So one rule to remember is that if it's an even number, you're going to have even roots. If it's an odd number, you're going to have odd roots. And so on this one, we're looking for 2 numbers that multiply to make 64. Then we raise that to the first power. So the 2 numbers are 8. 8 and 8 multiply to make 64, so 8 to the first power is 1, or 8. So looking at the next one, a little different because on all of these problems, we always raise those to the first power. Now we're raising it to another power. And so we do it the same way, though. 2 roots of 25, and then I raise that to the third power. So take the roots first, it'll be easier. And so it'll make the numbers smaller, so this is 5. So 2 numbers that multiply to make 25 are 5 and 5, but then I have to raise it to the third power. So that's the same thing as 25 again times by 5 makes 125. So look at this next one, 3 numbers that make 27, but then we raise that to the second power. So we saw before how 3 numbers that make 27 are going to be 3, 3, and 3. So then we take that 3 and we raise that to the second power, which gives us 9. And look at this next one. We've got 4 roots of 16, but then I'm going to raise that to the third power. And so I end up with 2 to the third power, which is just 8. So those are rational exponents. Let's look at the next type of problem. Here we're taking these simplifying expressions with rational exponents. So simplifying means we're going to try to make it so we only have one base of that type, and we're going to take any coefficients and multiply them together. That's what we have here, 2 2's. We're using that commutative property, bringing those 2's together, and then we're just adding the exponents since things are being multiplied. And so when I do that, I have 4c to the 4/5 power, and that's going to end up being simplified there. So looking at this next one, we see that we have n's, and we have n to the 1/3 power, and we have n to the 4/3 power. So we're going to add up those exponents. And so when I add up n to the 1/3 and 4/3, that makes n to the 5/3 power. We're just going to leave the answer just like that. And so on the next one, we see that we have b and a c. So we can't combine those, but here we have this b and this b. Those are the same base, so we're going to add those exponents. So 2/3 plus 4/9. We have the same thing here. We have c. Those are the same base. So we have c to the 2/5 and 9/10. So we add the exponents. You're going to come up with a common denominator, though. So I'm going to multiply this by 3/3. So the 2 becomes a 6, and the 3 becomes a 9. So now we'll be able to add those numbers. So we have b to the 10/9. 10/9, how did I get that? Well, 6 and 4 make the 10 right there. And then c, well, we got to change the denominator so that they're the same. So this becomes a 4, and oops, let's see, this is a 2 here. So 2 and 5 end up giving me 10. And so now we have the same denominator, so we can go ahead and add those 2 numbers, and that makes 13/10. So that would be our answer. Taking a look at the next one, same sort of thing. We take all of the numbers. Doesn't matter that the 3 is in front of a j and the 7's in front of a m. You're just multiplying all of those common bases. So when we go ahead and do that, looks like we have 21 and 21, and that gives me 441. And then I'm going to go ahead and take a look at my bases. So I have 2/3 and I'm adding on, looks like 1/6. And then for the m, I have 1/4, and I have to add on 3/2. So go ahead and do some work there. I've got to come up with a common denominator, so I'm going to multiply the 2/3 by 2/2, so that makes 4, and 4 and 1 are going to end up giving me, so let me go ahead and rewrite this number, are going to give me 5/6. And so same thing here, I need to multiply the 3/2 by 2/2, so this becomes a 6, so I will add it across, and I've got 7/4. And so that will be our answer. Let's take a look at the next problem here. And these are scientific notation problems. So simplify each expression, write each answer in scientific notation. And so let's take a look at the first part. It's the same sort of thing we had done on the last few problems. We're taking the numbers in front of the power of 10 and we're multiplying them. So the 9 and 3 get multiplied. And then times by 10, and then you get to add up those exponents. And so 7 and -16 give us -9. We subtract since they're opposite sign. This makes 27. Now this would be fine if this is how scientific notation goes, but it doesn't. So remember, scientific notation goes in this form. Some number times by 10 to a power. And a has to be between these two values. So the absolute value of a, because a could be negative, has to be smaller than 10 but greater than or equal to 1. And so you see how we have a number in the tens place. It's bigger than 10. So that means I need to make this one smaller. So I need to move its decimal over. And that means I need to make this one bigger. So I need to add one extra 10 here. Multiply this by 10. And that's going to make the 2.7 times 10 to the -8th power. Well, let's take a look at the next problem. And it says we have 0.5 and 0.3. So we're going to take those two numbers and multiply those two. And then we're going to add up the exponents, -6 plus -2. So this is going to give me 0.15, so 15, and then move the decimal over 2 spaces, and then times by 10 to the -8th. Well, I need to move that decimal over to the right this time, make that bigger. And that means I need to make this one smaller, so I'm going to subtract 1 from that. And so that's going to make this 1.5. So basically I multiplied this by 10, means I have to divide this by 10 to keep it in balance. So 1.5 times 10 to the -9th power is what we get there. So on this one, we have 0.2 times by and then 4. So that's going to give me 8, but then I got to move the decimal point over 1 space, so it's 0.8. And then times by 10 to the 5th plus -12, which makes -7. And so I can go ahead and make the number here 1 space bigger by multiplying it by 10. That means I have to, if I made this one bigger, I got to make this one smaller. Subtract 1 from the exponent or divide it by 10. So that makes this 8 times by 10 to the -8th power. So those are the types of problems that we're going to see on the homework. Good luck.